All right, let's take a look at this problem from 6.2. Okay, so you want to kind of look at all the variables and decide which one might be the easiest to eliminate. And I'm looking probably at trying to get rid of x because I can see that I have a positive x and a negative x, so that's already ready to go. And this other number is not too large, so it wouldn't be that bad. So I'm definitely going to put equation A with equation B. Now we're going to try to get rid of x. So nothing really needs to be done because they're already opposite of each other. Take that. All right. So when we add downward, let's see what we get. So x minus x is 0, so it's gone. Negative 3 plus 8, that's going to make that 5. And negative 1 take away 4 is negative 5. And 9 minus 24 is negative 15. Now, one thing that I am noticing is that 5 goes into all of these numbers. So I might just divide every single number by 5 just to shrink this down a little. This isn't a requirement, but it is nice to deal with these smaller numbers. So remember, this is our equation D, okay? Now we're going to put two other equations together. So I'm thinking about putting B and C together because they have opposite signs. Now remember, if you got rid of x when you put the first two together, then you have to get rid of x. Again, you have no choice. Now, in order to make these cancel with each other, I'm going to have to multiply this equation right here, equation B, by a 2. So that way, when I distribute, I'll get a negative 2x. That'll cancel with our positive 2x. All right, so I'm going to do negative 2 times equation B right now. Okay. All right, so if we do negative 2 times this first term, we're going to get negative 2x. I'm sorry, we're going to get positive 2x. You know what, you guys? Not a negative 2. What am I talking about? We want to multiply by a positive 2. So if we multiply by a positive 2, we're going to get negative 2x. If we multiply the 8y by a positive 2, we're going to get 16y. The positive 2 to the negative 4 will make a negative 8z. And then a positive 2 to the negative 24 will make negative 4. Just stare at that really quickly and see if I double them all. Looks good. We're going to bring down equation C completely unchanged. Let's see what we get. So 16 minus 15, we just get 1y. And then negative 8 plus 7 is going to be negative 1. And negative 48 plus 45 is negative. So here's our equation E. Now remember, you put D and E together. Now notice they're the same exact equation. Whenever that happens, it's infinitely many right away. But let's say that you can't see that, right? That it's an infinitely many. A couple ways you could think about it is if it's the same line, if I was graphing it, it'd be one line, and then it'd be the same line on top of that line. So they would be touching infinitely many times, right? All along that line. Another thing you can do is you can write down, let's say this is equation E, and I'm going to bring equation D down, but I'm going to change all of its signs. I'm going to multiply by a negative 1, in other words, because I want to try to make the y's cancel, let's say. So I multiplied this equation right here by a negative 1, so I could get all opposite signs. And when I cancel downward, everything cancels. So it's technically 0 equals 0. And we know 0 equals 0 is our infinitely many case. Now, it isn't enough just to say there's infinitely many solutions. We're going to have to take this to the next level. Okay. So this is on your final. So I don't want you to blow this off because it's hard and be like, well, I'll just take the L on this problem, right? No, because then you'll be taking the loss on the final exam. Okay. So what I'm going to do, I'm going to go into great detail here, right? On what's going on this problem. Okay. So you're going to go to one of your boxed equations and you're going to pick the easiest variable to solve for. I can see that y is going to be really easy to solve for if I just move the z over to the other side and make it a positive z. Now, what this does is for our ordered triple, it tells me two of the values. It tells me, remember how it goes x, comma, y, comma, z? It tells me that y is z minus 3. And because everything has to be in terms of z, Z is going to stay Z. So the only thing that we need is X in terms of Z. So I'm going to go back to the beginning and pick any equation that has X in it. Now, for me, this one looks the simplest because it has X with, a 1 in front of it, which is our ideal. So I'm going to take that equation and I'm going to solve for the X in that equation. So we're going to have to add the 3y over and add the Z over. So on the other side, they'll both be positives. But this isn't allowed to be plugged in because remember, you can only use one variable in your ordered triple, and the variable we've chosen is Z. So I'm going to have to get rid of the Y. So in Y's spots, we're going to go ahead and write what we got right here. Remember that Y is Z minus 3, right? So now if we do the math here, we will have X in terms of Z. All right, so we get a 3Z when we distribute. We get a -9. And let's see what this ends up becoming, you guys. So 3Z plus 1Z gets us 4Z, and -9 plus 9 is gone. So we have 4Z as our X component, okay? So this, watch the video a couple times, make sure that you understand the process. Let me just sum it up. You go to one of your boxed equations and pick the easiest variable to solve for, okay? Then you're going to take that and write it down in your ordered triple. Then whatever variable is missing, you're going to go back to the beginning and grab the easiest equation to solve for that variable. Once we solve for the variable over here, you notice that we still had a Y and a Z. We can't have that. We're only allowed Z's. So take what you got over here from the first part and substitute it in. Now let's go put it in and make sure it's right first. Okay, so 4Z, Z minus 3, and Z. All right. 4Z, Z minus, let's see, 4. Oh, there it is. Yeah, it is right. So 4Z, Z minus 3, and Z. Perfect. Okay, now, I just want to make sure that you understand what it is that you're finding. This is going to generate all of the ordered pairs on that infinitely many, on the intersection of those 2 planes or 3 planes, okay? So somebody can go in here and pick a number. Let's say they pick Z equals 0, and then let's say that they pick Z equals 1. I'm just going to plug them in my head, you guys. So I'm going right here. 4 times 0 is 0. 0 minus 3 is -3. And 0 is 0. So that's going to be one ordered pair. Now let me substitute 1 in. So 4 times 1 is 4. 1 minus 3 is -2. And if we plug a 1 in for the Z, we get a 1. And we can pick another number, pick a 2, pick a 3, pick a -1, pick a -2. And we're going to get points on the intersection of these planes. So just to kind of remind you, let me go into GeoGebra and show you on the 3D grapher what this looks like and why this is important. Okay. Oops, I did not pick a 3D grapher. Let me try this again. Calculators. There it is, you guys. So I'm going to type in the planes that they gave us in the beginning, right? So what was it? X minus 3y minus Z equals 9. -X plus 8y minus 4Z is -24. And finally, 2x minus 15y plus 7z equals 45. Now, those are our 3 planes. Now, let me just really quickly make it to where they're different colors because it's just a little bit too much of that teal color for my liking. Okay. And I'm also going to turn it on. So there we go. Okay. So we can see that all 3 planes, the purple, the red, and the green, touch, right? They all touch right here on this line right here, right? Okay. Now, those ordered triples that we got, what were they? 0, -3, and 0. Let's go type that in. 0, -3, and 0. Boom. Notice the point showed up right there on the intersection, okay? And then we had, what was it? 4, -2, 1. Yeah, there it is. So you're giving people a formula where they can plug in one number for Z, right? So there's only one variable, any Z they want. They'll plug it in and it'll generate one of the infinitely many solutions where these planes cross. So this is a much better answer than just saying infinitely many. When you say infinitely many, you're just going, okay, well, there's a lot of them. Well, here you're saying there's infinitely many, but you're also describing the infinitely many. So this is why this is valuable to us and why we take it to that extra step, okay? All right, thank you so much for joining me. Hopefully this helps you with your problem on 6.2. Take care.